Hello everyone, my name is Vikrant Rathole and I am partner of OOB Consulting, and we have designed this VRiddhi Estimation Software for the machining industry. And in this video we are going to check on the operations, how we are going to work with operations. For faster time movement, I have already prepared a setup so that we could directly enter into operations. So this is the operation demo. To start with any operations, we will go to operations menu and add operations over here. If there are no machining operations in any of the setup, it will inform you like there are no operations. If I try to say add operation, there are no operations to add in this setup. Okay, so we have it in CNC lathe. We will just go through the complete operation list what we have, and then probably complete one of the operation over there. So very first thing I will do is click on add operation. A new page opens up. This is the main page where we will do the fill in the blanks. So the software is designed in such a way, if you miss any of the input, it will not allow you to proceed further. For simple example, if I try to start or select any operation, it says the operation name cannot be blank. So very first of all, I will give it an operation name. Overview. This safe distance is coming from the setup where you have keyed in this safe distance. You could change it over here also if you need to do it for the specific operation. Right? Now let us have a view on the list of the operations that have been covered under turning. In turning, very first of all, we have the bar feed, then we have burnishing of hole, burnishing of OD, profiling, that is counter turning G02, G03, drilling, facing, grooving on the face, grooving internal, grooving on the outer diameter. Then idle. Idle is specifically been kept so that if there is some of the operation which you are doing and we have not covered it, you could select this idle and put the minutes that you are going to consume for this operation. So that's the reason why we have kept that an idle. Then we have knurling, we have parting, we have reaming, we have straight turning internal, that is something which is boring like. Then straight turning outer, that is OD turning, outer diameter turning. Taper turning internal, taper turning outer, threading internal and threading outer. So if you need to find out and quick this thing, so we can go to straight, I directly come to that menu. So let us start exploring one of the straight turning outer diameter. As soon as I select this, the required parameters which I need to key in, they are been reflected over here. One of the things which is important, what we have considered, is tool path strategy. As we all know, we have the option of using the facing strategy or the turning strategy, that is G71, G72. So if you are going to work by using canned cycles, you should select the tool strategy. In fact, without selecting the tool strategy, the estimation will not proceed. So at the moment, we'll start with turning. Then the next selection what we have is single tool and multiple tool. Multiple tool in the sense, if you are going to do is roughing and finishing of the same operation, you need not create is one more operation. You could probably finish it out over here itself. So let us keep it single tool. In the same video, we will also cover the roughing finishing tool, that is using two tools. Then selection what we have over here is G96, that is constant surface speed and set RPM. Please note the set RPM is set at the maximum turning diameter. The reason is, since your tool life is directly dependent on the surface speed first, then the feed and finally the depth of cut, we have restricted it to the maximum cutting diameter. Then you have to key in all the surface speed, tool feed and feed. This we have two options. You could go check into what is your database and select what exactly you would like to consider. You can even change it over here if you need to. So everything is flexible. Then let us start with 100 dia. We will turn it down to 50 dia. Then turning length, let us keep it 100. Over here we have the selection of limit RPM. Limit RPM is one of the thing which is very essential, because most of the time due to tool holding or maybe the work holding, you have to restrict the RPM to a certain value, and that is the reason why we have put a limit RPM. For simple example, when you use this constant surface speed, most of the programmer have the tendency of limiting the RPM to not to the maximum but to slightly below the maximum RPM. So this we will also cover this in the further video itself. One more selection what you have is continue tooling. Like for simple example, in turning there will be multiple steps which you have to turn, but it will be happening with the same tool. So you could use this continue tooling, and the same tool, the tool change time will not be considered when you select this. We will cover this also in further video. Okay, so now what we have is surface speed, we have the depth of cut, we have all the required dimensions which has already been keyed in over here. If there are some comments, you could mention your comments over here. Click on calculate operation, you get the process RPM, the feed per rotation, cut length, what it is going to be, the non-cut length, cut time, non-cut time, total time, and the scrap that has been generated by due to this turning. So let us play with the things available with us. Now with single tool, with turning kind of strategy, this is the output of the time. Let us select on facing. What happens if I select facing and calculate operations? The time increases to 26.59 from 24 something that was, I didn't recollect it now. So this is the difference what you could check when you are doing this kind of operations. Now let us find out what is the difference in timing when we move from set RPM to a constant surface speed G96. If I use G96 and click on calculate, my time reduced to 20.49. If I go to turning and calculate operation, it is 18.23 from 24. 24.47. If I use this constant surface speed, it is 18.23. If you change the depth of cut from 1 to 2 mm, calculate. So I will just brief you for this operation itself, like how the calculation has been worked on, how we are working on the tool paths. So as you could see, the start diameter is 100, but you have a safe distance of 1 mm. So the start diameter for practical tool path will be 102 mm. Same way, the turning length what you are keyed in over here is 100, and there is a Z of 1 mm, that is an safe distance in Z axis of 1 mm. So your practical tool movement is of 101 mm. So let us first find out the number of cuts that we are going to go for. From 100 to 50, we have is 50. Okay, let me calculate it. 100, sorry, it is 102. 102 minus 50. 52. 52 is the diametral difference that you have to turn it down to. This is divided by 2 because since x-axis is the only thing which will be moving, your practical x-axis movement is 26 mm. So considering the depth of cut divided by 2, you will be having is 13 depth of cut. Your length is 100 plus the Z. So 13 into 101. 1313 is the actual cutting which is going to happen. Then why we have is 1339. This 1339 is nothing but every time the depth of cut will increase by 2. So 1313 is 13 into 2 is 26 plus 1313, 1339. This is your actual length of cut. Similarly, the non-cut length is also been calculated with respect to the tool paths, and high complex mathematical formulas have been used to calculate this tool path. We will not be discussing each and every tool path calculation because we feel it is a proprietary information which we would like to safeguard it with us for the moment. Now let us have a look at rough finish using two tools. So what we are going to do is roughing and then finishing with a separate tool, or maybe an separate speed feed data using the same tool. So let us have a look. The very first thing what you have to key in the finishing allowance that I am going to keep for the second tool. So let us keep it 1 mm and Z. I think if you need, you could keep it, or if you don't need it, just eliminate it out. But if you keep it Z, it will automatically calculate in that manner itself. Again, I will select the tool. Select tool. Now this I will increase it to 0.2 and this I will bring it to 1.8, 0.18. Sorry. And depth of cut I will reduce it to 1. So now what is happening? We are going to do the same operation of turning from 100 dia to 50 dia over 100 length, but using two tools. Calculate operations. This is the timing what you have. It's the same formula what we are going to work with. You have an RPM of 1180 because this diameter, your 100 diameter at the time of finishing operation will be coming down to almost 52 mm. So that is the reason why the RPM has been increased. Let us check with set this thing, calculate operations. 1180 is the RPM that it comes to. Now let us restrict this. Now 625 is your RPM, which is on set RPM, and 1180 is for the finishing operation. Let me limit this RPM to say 800. Got it? Now your CSS, even if you use this constant surface speed, it will not exceed that 800 mm, and your timing are been calculated based on that only. So this is how the whole toolpath generation or cut length generation and non-cut length generation is been working around. So we will cover some of the operations, not all the operations, because the person who knows machining, I don't think he requires further information on this. So I will say we have already calculated this, just calculated, save operation and close. As soon as you do that, it comes into your setup, same setup. You have these two operations that are going on. Let us review on modify operation. Once you click modify, the whole thing comes up again. Now assuming is we are using the same tool, but we are just changing the feed and depth of cut. Then I could say is continue tool. Now just modify. Since it has been already been saved, it is asking me verifying whether I would like to modify the inputs. I would say yes, modify. Okay, now what we have done, we have removed the tool change time from here. So it should make the difference of that 3 seconds or 4 seconds, whatever has been inputted over here. Calculate operations. Yes, it has already been changed. 1.45, sorry. I remove this continue tooling. 1.50. So this is how you are going to work with most of the operations. I will save and close this. Add operation, second operation will continue with. I need to give it a name. So most of these operations are similar. There is absolutely no this thing. So we will cover probably one of the grooving and this counter turning cycles, because this is a bit tedious, and the only way we could find out was using this tedious method. So thanks a lot for watching this video. Do keep watching. The whole machining operations, drilling, then reaming and all this thing, we will be covering it in a separate video, because these operations will remain common in turning as well as milling, so we will separately cover it. So thanks for watching. If you have any suggestions or comments or any recommendations to be made, do send it to us. We would like to receive them on support@VRiddhiTechnosoft.com. So do write to us. Thanks, Etan. Have a great day ahead.